Okay, so here's our agenda for today. Your warm-up is a pretty easy one. You're going to determine which wheel you would spin to win a prize. And then we will talk about normal distribution, what that is. We'll do some practice, and we'll collect some class data. And actually, we didn't have a lottery project, but we do have a project. So some of you will be making up work after that. Okay. All right, so our goals for today are to understand what standard deviation tells you about a data set and use normal distribution probabilities to answer questions, and always ask and answer questions. So this one is your warm-up, and the reason I wanted you to open your slides is because you can actually click these links to find these wheels. Yeah, I'm hoping it's coming. Yeah, there we go. So this is the first wheel. You can see the prizes on them. If you click it, you can find, I just won $5,000, lucky me. Okay, here's the second wheel. And you can click it, and I won 10,000 on this wheel, which is actually very, very lucky. Oh, yay. Okay. All right, so the question is, which wheel would you rather spin? Even if your computer is not up yet, you can still look at the prizes that are the choices to see which one you would rather spin. And then, so you're going to circle one that you would rather spin. And then for number 2, you're just going to explain in a sentence what's the difference between the two wheels. So take a minute. You may spin the wheels a few times if that helps you think it through, or you can just decide based on the numbers that are on your paper. Okay, so let's have you raise your hand if you chose wheel 1. Raise your hand if wheel 1 was the one you wanted to spin. I see 1, 2, 3, 4, 5 hands. Okay, good. Raise your hand if you chose wheel 2. 1, 2, 3, 4 hands for wheel 2. Okay, what is the difference between the two wheels? Who can raise their hand and explain? Dion, what did you put for the difference between the two wheels?
One has no prizes below 4,000, so you have a better chance of winning.
Okay, so Dion said that one of them has no prizes below $4,000, so you have more chance of winning more money. Kenny, what did you write? Wheel 2 has a wider range of prizes. All right, do you guys understand what Dion and Kenny have told us there? Okay, so wheel 1, you're guaranteed at least $4,000. Wheel 2 has a wider range of prizes. Some of you guys were willing to risk it, right? Because you wanted that higher prize. And some of you wanted to play it safe with wheel 1, where you're guaranteed $4,000. So please write your own answer to number 2. You can borrow from the information that Dion and Kenny shared with us. Dion told us one of the wheels has no prizes below 4,000, and Kenny told us that wheel 2 is more spread out. All right. So here are some definitions that are going to help us as we go forward. We're going to need to remember that the mean is the average. Standard deviation is a new term for us, and it measures the spread of the data about the mean value. Now, last class we used a different word for spread. Do you guys remember the word we used last class? Starts with R. Who remembers it? That was a good guess. You weren't here last class, right? Yeah. So last class we used the word range. Remember that? Range was the largest minus the smallest. Standard deviation measures spread in a different way. It's not largest minus smallest, but it does measure the spread, and we're going to talk about that today. Normal distribution is also what this whole unit is about, and it's a function that represents distribution of variables in a bell-shaped graph. So that means in a bell-shaped graph, most people are in the middle, and then some people are a little bit farther from the middle, and then not very many people at all are very far from the middle. And you'll see examples. All right, so this one's not on your paper, so you can look up for this one, or you can be looking at your own slides. We're on slide 6. So on slide 6, it says data can be distributed or spread out in different ways. So you can see that it's more spread out on the left here. You see you've got a lot of data on the right, and then on the left, you can see the number is kind of spread all the way to 40. It could be more spread out on the right. So you have a lot of data on the left, but on the right side, what happens is it spreads out to more numbers. Or it can be all jumbled up and have no pattern at all. All right, but this is a special case when your data is normally distributed. And that happens when you get a lot of values in the middle, you get some values that are close to the middle, and you get just a few values that are far from the middle. It's called a bell curve, and this curve right here is called, inside it is called the histogram, and then this curve here is called the bell curve or the normal distribution. So not everything is normally distributed. Some numbers are just like all over the place, but here are some things that could be normally distributed. Heights of people. So most people are about average height, and then some people are a lot taller or a lot shorter, but most people are about average height. Size of things produced by machines. So for example, like if that bag of chips that you get, if it says it's like 4 ounces, it's usually not exactly 4 ounces. It might be 4.001 ounces, or it could be 3.95 ounces. It's about 4 ounces. All right, so the size of those things produced by machines are also normally distributed. Errors in measurements are normally distributed. So if I gave everybody a 6-inch piece of paper and asked you to measure it, some of you might say 5.9 inches, some of you might say 6.1 inches, right? But you'll all be very close to 6. Your blood pressure is normally distributed, and sometimes grades on a test will be normally distributed, where most people get some sort of average grade for that class, but some people get really low and some people get really high. Last class we talked about mean, median, and mode. Remember, mean is the average, median is the middle number, and mode is the number that shows up the most often. When your data are normally distributed, the mean and the median and the mode will all be the same number. And that shows that you have symmetry. So here is another little game that we can play just to see a normal distribution. It's kind of fun. We're on slide 8 right now. So if you are not on slide 8, I recommend that you go there and you click this little button at the bottom that says play. And what we're going to do is we're going to keep the left right at 50-50. That should create our normal distribution. You can speed it up if you want to see it happen a little bit more fast. And what's happening down here is the balls are falling and they should start approaching a normal distribution. It doesn't happen right away. In the beginning, there's some variability, but as you continue, it should be pretty normally distributed, where you've got a lot in the middle and then just a little bit on the sides. Okay, that's pretty good there. The 13 and the 8 aren't perfectly even, but the other ones are pretty even, pretty symmetric. All right, take a minute to play that, and I'm going to come in and check on you. Remember, that link is on slide 8. All right, so this one is on your notes. So you want to turn to page 2 of your notes. Now, we said most of the data is near the mean in the middle, and here's where you can see 68% of the data will be near the mean within 1 standard deviation. All right, 95% will be within 2 standard deviations, and almost all of your data, 99.7%, will be within 3 standard deviations. Okay, and that's why they say that with like intelligence testing, if you are 3 standard deviations above the mean, you are a genius, because you're like up here with less than 1% of the population. Okay, and then here the same numbers are just broken up into the parts. So I told you 68% are within 1 standard deviation of the mean. That means 34% are 1 standard deviation above, and 34% are 1 standard deviation below. So these percentages are going to help us answer questions later. All right, who can ask me a question about this slide? Okay, I think you're still processing, but when your questions come up, let me know. Okay, and this one is also on your paper. So I'm going to switch over to my paper so that we can work through this together. If you haven't grabbed a pencil yet, pencils are on that bottom shelf. Okay. The heights of American males are normally distributed with a mean of 69.5 inches. What's 69.5 with in terms of feet? How many inches in a foot? 12 inches in a foot, right? Okay, so 12 times 5, I'm just trying to figure out how tall this is. 12 times 5 is 60, okay? So that means that 5 feet is 60 inches. So this would be 6 feet and 9 inches. Sorry, not 6 feet. What am I thinking? You guys need to yell at me when I say things like that. 5 feet, 9.5 inches. 5 feet, 9.5 inches. That is the average height of an American male. All right. Where do you see the mean of 69.5 on the graph? Look at the graph. Where is it? Dion says in the middle. Anybody else find that in the middle? Yeah? Yeah, it's right here, 69.5. So it's in the middle. So the mean goes in the middle. All right, this is a harder question. I'm going to give you a minute to think about it because you don't actually see the number right there on there. You're going to have to figure out where it comes from. The question is, where do you see the standard deviation of 2.5 on the graph? Now, it's not this one because this is 2.35. The number is not actually printed on there, but you can figure out where it comes from if you really do some thinking. So I'm going to pause for a minute and come walk around while you're thinking about where that 2.5 comes from. If you think you figured it out, write it on your paper. Kenny, can you explain to us where the 2.5 comes from? Okay, he said it's between each of the marked heights here. So if I go from 69.5 to 7.2, how far did I go? 69.5 to 72. Close, 3. Shelby, yes, 2.5. So the distance from here to here is 2.5. Does it work for the next one? Going from 72 to 74.5, did we go 2.5? Yeah. All right, so we got it. The standard deviation of 2.5 is, we could either say it's the distance between the standard deviation lines, or we could say it's the difference between the numbers on the line. I'm going to go with distance, but if you prefer difference, that's okay. All right, so it's the distance. Oh, I'm going to use difference also. It's the distance or difference between the standard deviation lines. All right, so if I wanted to make this chart myself, I would start by putting the mean in the middle, and then I would add 2.5 each time to get the lines over here, And I would subtract 2.5 each time to get the lines over here. 50% of American males are shorter than what height? So 50% is the same as what fraction? That's good. It is 1/2. So if we're looking for half of the males, we would be looking for that number in the middle. So 50% of American males are shorter than, what's the height that we had there? Can somebody read it to us? The height in the middle? Right. So 50% of American males are shorter than 69.5 inches. All right, this is a slightly harder question because we've got to put together some information now. 84% of American males are shorter than what height? I'm going to give you a minute to think that. It's going to be one of the heights here, but you might need to add up the percentages to make sure you got the right number. So the question is 84% of American males are shorter than what height? All right, Shelby got 72 inches. Did anybody else get 72 inches?
Yeah.
Dion did, Stephanie did. Anybody else? Kelly did? Okay. All right, so let's just check their answer real quick. I'm going to use Desmos to check their answer. And what I'm going to do is I'm going to add up all of the percentages less than 72 to see if that makes 84%. So I need a new Desmos. All right. So I'm going to add 0.15% plus 2.35% plus, oops, I missed a 5 there, 13.5%, 34, and then I have another 34 to get up to 72, and it does make 84. You see that? So I added all of the values to the left of the 72, and that did make 84%. All right, so it's 72 inches. Because 0.15 plus 2.35 plus 13.5 plus 34 plus 34 made 84%. But this is your answer. All right, make sure you have that, and then we are going to turn the page. Okay, so let's start by just filling in your percentages. So we have in the middle 34 and 34. Notice that there's symmetry. And then we've got 13.5 on each of these. And then these, I can't fit it in there, so I'm going to write out here 2.35%. And then finally at the end, we have 0.15%. That means less than 1%. That's really small. All right, so the question says, Ben is really hoping to get at least 16 yellow M&Ms. What is the probability he gets 16 or more? So I'm gonna pause while you figure out the probability that he gets 16 M&Ms or more. Remember that you're gonna use the percentages that you just added. Okay, raise your hand if you think you have an answer for us. Anybody find an answer? Elisa, did you find one? So here's the 16, Elisa, right? One way to solve it is to add these numbers up. Yeah, so go ahead and do that. Just a little bit louder. All right, and while we're waiting on you, Lisa, to do that one, who else has an answer so we can compare them? Shelby? So Shelby's getting 84%. Is anybody else getting 84%? Kenny? Did you get something different? What'd you get? So Kenny got 16%. So do you guys see how they're looking at different sides of the graph? Shelby's looking at the left side of the graph, right? And Kenny's looking at the right side of the graph. So looking back at the question, what do you guys think we should do? Should we go left side or right side?
Right.
Okay, so a lot of people were saying right side. So do you see there? Yeah, so Shelby gave us some really important information. What was that? Yeah, yes, right. Excellent. All right. So good job, everybody. Lisa, were you able to confirm 16? Good. All right. So that's funny because it's 16 M&Ms and it's 16%. That's not always going to be the case. That's just a coincidence there. And actually, Shelby also gave us some other really important information because it's actually easier to find the 84% than the 16%, and here's why. We know that 50% is in the middle, so I don't actually have to add up all those numbers. I know that's 50%. And then I can add that there, that's 34, that's 84%. So if I wanted to do this problem in my head without decimals, I've got 50% plus 34% is 84%, and then subtract that from 100 to get 16%. So there are some shortcuts here. You don't have to work with the decimals all the time. All right, so this is your partner problem. And let me just move forward in our slides. I do have some suggested partners for the project. However, this partner problem, nobody's going to work alone. So these are for the project. Lonnie, I know you want a partner, but we need to find somebody who wants to work with a partner to get you one, okay? So if you have a partner here, that could be your partner for right now. Yulisa will work with Araceli. Sarah will work with Kai. Emra's not here. Kelly, you can work with Shelby. So Kelly, just pull your desk back so you can work with Shelby on that one, okay? And Nadim and Joseph and Eamon and Dion. And so let me see those of you who don't have a partner, I'll partner you up. This is the problem you're going to work on with your partner. Sophie hates red M&Ms. Each bag has a mean of 10 red M&Ms and a standard deviation of 4. All right, so I would like you to please fill in the deviations, fill in your percentages, and then answer the question. Work with your partner on this. Let's see, unfreeze. Okay, so down here, some of you filled in all of the percents, but some of you didn't. You just filled in the ones you need, because less than 2, here's the 2, right? So we said that this section is 2.35%. And this section is 0.15%. So the probability you get less than 2 red M&Ms, I saw a lot of you added those together to get 2.5%. And I did see a lot of you working really well with your partner, which I appreciated. Let's go to the next page because I need to poll you. Okay, now most of you can take a quick break while I'm polling you, but you need to, during your break, answer my question. So how much do you agree with this statement? Students should be allowed to stop attending school after middle school. Okay. So when most of you added these numbers up, I saw you got 37. Does anybody disagree with 37? So now let's just see if we can round this right. I'm going to round it to 1 decimal place after the decimal. So let me go back here to Desmos, and I'm going to do 37 divided by 13. Okay, if you round it to 1 decimal place, the 4 is less than 5, so you keep it at 2.8. So we're going to round this to 2.8. Now, does anybody remember where we put the 2.8 on the graph? Good. So we're going to put 2.8 in the middle. Now, if we knew the standard deviation, we would be able to figure out the other numbers. So we're gonna find the standard deviation using Desmos. So you can do Desmos on your computer or on your phone, but I need you all to try it. Here's how we're gonna do it. Okay, you're gonna start with the command stdev, that's standard deviation, and parentheses. Please open your Desmos to do this because you're not gonna remember it if you just watch me do it. And then we're gonna put in the list of numbers with commas. So I've got 1 comma, 2 comma, 2 comma, 2 comma, 2 comma, and then I've got 5 threes, 3 comma, 3 comma, 3 comma, 3 comma, 3. I've got 4 fours. No, I've got 2 fours, and then I've got a 5. All right, so put that 5 in there, and then once you do that, it will tell you the standard deviation. I'm gonna come around and see that you have started this on your Desmos. All right, so the standard deviation is 1.1. So remember we said standard deviation, that's the distance between the lines. So the next line is gonna be 2.8 plus 1.1, which is what? Good, 3.9. And then if I add 1.1 again, get 5, and then 6.1. And then on this side, instead of adding 1.1, what do I do? Yeah. So 1.7. You guys let me know when I make a mistake. 0.6. And then you get a -1, which doesn't really make sense, but you still write it. Negative 0.5. Okay, and we still have the same percents. Okay, so 68% of the students, the middle 68%, they chose between what numbers? What are the numbers for them? Here's your middle 68% right here. See it? What numbers did they choose between? The low number is? Yep, and the high number is 3.9. So they chose between 1.7 and 3.9. Now 1.7 is closest to 2. So that would be disagree a little. And 3.9 is closest to 4, and that's agree a little. So most of you were in the middle. Not many people had really extreme views, like agree a lot or disagree completely. Most of you were somewhere in the middle. All right, so we're gonna do this last problem. I'm gonna have you guys set your phones down so we can do a last problem. And then after the last problem, we will either work on the project that was due before break or other makeup work, or you can do something for another class. So one more problem for this, okay? All right, so remember our warm-up question. Some of you weren't here for the warm-up. The question was, which wheel would you rather spin to win a prize? And about these, Dion noted that for the first wheel, you're guaranteed to win at least $4,000. And Kenny noted that for the second wheel, the prize values were more spread out. The first question is, without calculating, I can see that the mean of both lists is 5,000. How do I know that? So look at these numbers here and think, what is it about these numbers that lets me know that the mean is 5,000 without even calculating that? If you have an idea, you can write it down. I'm going to give you a minute to think. I'm going to walk around, but study those numbers. All values are pairs that average to 5,000. For example, 6,000 and 4,000 average to 5,000. All right, we're going to use Desmos to find the standard deviation. I know it's a lot to type, so I found the standard deviation of the first wheel for you. So I want you to find the standard deviation for the second wheel. That's this one right here. I'm going to zoom in on those numbers in case you want to look at them as you are typing. Okay, so the numbers that I underlined, 5,000, 8,000, 2,000, those are the ones you're going to do STDEV and then parentheses. Okay, I'm going to show you really quick about the STDEV again. Remember this STDEV? Parentheses, and then you're going to start typing the list. I'll put it back up for you in a sec. Okay, like that. Let me put it back up. Don't put commas in your thousands because that will confuse them. So you're going to type 5000 with no comma in it, and then you need a comma. Actually, it's going to look like this. Say 5,000, 8,000, no commas in the thousands, just a comma in between them. Otherwise, Desmos gets confused about what number that is. I do need you all practicing this so you'll be ready on your project to find standard deviations. Yes. All right. What'd you get, Sarah? Oh yeah, look, you put a comma in your 2,000. Yeah, okay, now I got the same thing too. That's what I got. Anybody get the standard deviation yet? You put one back in there, did you? All right, I saw some of you had answers. I didn't get to check in on the far side of the room. If you're on the far side of the room, raise your hand if you have an answer for standard deviation. All right, I'm going to take Sarah's answer since you guys aren't helping me out there. Go ahead. Yeah, and I think I'm going to round that 7 up because of the 5 after it, right? So let's round it to 3,408 because if this number is 5 or more, it goes up. So on number 2, let's put the standard deviation for the second wheel is 3,408. I didn't do a decimal this time because I already had a lot of digits. I didn't need it. Okay, so the first, this is wheel 1. This is wheel 2. Wheel 2, remember, is the one that's more spread out, and you can see that because wheel 1 had a standard deviation of 695, but wheel 2 had a standard deviation of 3,408. All right, the standard deviation doesn't go in the middle. What number goes in the middle? Good, 5,000, the mean. So remember, the mean goes in the middle, so I'm going to put 5,000 here. And then the lines are going to add the standard deviation to get the next line. So I'm going to add 5,000 and 3,408 to get 8,408. And then I'm going to add 3,408 again for this line. And I need a calculator for that because I can't do that in my head. All right, so we're going to label that. So it was 8,408 plus 3,408. So that gets me the next line, and I'm going to need one more line, so I'm going to add again. 11,816 plus 3,408. Okay, so these are the next two numbers I'm going to use. This one here is 11,816. I'll show you in just a sec. And then the last one was 15,222. No, 224. All right, so that's how they show up on my lines. 5,000, 8,408, 11,816, and 15,224. On this side, you're going to subtract the standard deviation each time. Bless you. So this next line is 1,592. This one, I don't usually go above, but I'm going to have to go above this time because I'm running out of space. So I'm going to subtract on Desmos to find that one. All right. So the next one I'm getting right here, this line I'm getting negative 1,816. That would not be a good wheel to spin if you're going to actually lose money for spinning the wheel. And then I'm going to subtract again. So negative 1,816 minus 3,408, and I'm getting negative 5,224. Okay. So in wheel 1, I had a 68% chance of winning, so I was probably going to win between 4,305 and 5,695. But for this one, I've got different numbers. Remember, your middle 68% is right here. So you're going to fill in the numbers from the start and the finish. And when you're done with that, you'll be done with your new work for today, and you can work on some of your makeup work. So we have a 68% chance of winning between, what's your low number? 1,000 what? Yeah, $1,592. And this one over here, $8,408. So remember, for the first wheel, you have a really good chance of winning somewhere around $5,000. For the second wheel, it's more spread out, but you might win low or you might win high. So it depends on how much of a gambler you are, which one you're going to pick, right? All right.